Okay, factorizing quadratics via Berry method this time. Okay, so 8x squared plus 22x plus 15. I've done this via completing the square, just to give you an idea of why you don't want to do that. You can fast forward if you want, but this is just running through how I did it. So take out a common factor of 8, cool, force it into a square, solve for this k, great. Then I've gone difference of two squares of these to get to there. From that, simplified those fractions. From there, simplified those fractions. And then distributed this 8 as a 2 and a 4 so that I can get rid of these fractions and ended up here. Now, this part's not so bad. This part is a lot of ugly fractions, takes a bit of time. Now, you could do that every time if you desperately wanted to. I'm going to suggest you don't, but sure, you can sign your own death warrant on that one. Because there were definitely a couple of errors in there when I did it, and I had to keep going back and forth to figure them out. Okay, so it would be nice if we didn't have to do this much work. So let's come up with a better method. I call this berry method, basically because you get these little twig things and it looks like berries growing off the tree, sort of. Other people have essentially the same idea, just they draw it slightly differently. They do what's called the cross swords, and there's a whole bunch of other names and slight variations. They're all doing the same thing under the hood. It's just the names and they look slightly different, but it's actually fundamentally the same thing. Cool, okay. So, before we even touch this specific example, let's consider a quadratic that is already factorized, where I've got something times x plus some constant, and something times x plus some constant again. If I expand that out, 8x by cx gives me ac x squared, and similar, expand all those out, I'll get these terms. These are both single x things, so I can put those into one thing. Okay, fine. Here's how Berry method works. And we're going to do this in a general, and then we'll do many examples to nail it down, because this definitely takes a bit of practice. Okay, we're going to take the first and the last term and multiply them together. So I've got A, C, B, D, A, C, B, D. Now the reason we do that, we've got all of the different variables, A, B, C, and D are all in there. Great, we're then going to find two things that are factors of this, so A, D, and B, C, and those two things are also simultaneously going to have to add to the middle term. Cool, once we've got that, we're going to factor these again, such that we've got A, D, B, and C all separated. The way we find those is we need factors of this, such that this factor multiplied by this factor end up being either, where is it? Sorry, this factor and this factor end up multiplying to the front, this factor and times this factor end up multiplying to the end. Now, that sounds really fiddly, and it is a little bit until you get the hang of it, and then it's like, okay, yeah, you know what you're doing, you're on autopilot. So, we're going to do that with this guy. We already know what the result should be, but we'll get there eventually. Okay. So, first thing you do for Berry method. Oh, by the way, you always go through your list. So, start at the list, top of the list, factor anything common, nothing in common, can't do anything with that. Okay, it's definitely not difference of two squares, it's not grouping. I could try to do completing the square, but that's a bit chunky, so we want to avoid it. Cool, next one now is Berry. So, take the first and the last term, multiply them together. So I've got 8 times 15, okay. So what do we get, 120? Yep. So I've got 120, okay. I want to break that into two numbers, okay. These two numbers are going to multiply to 120, but add to this middle number. So they add to this. Okay, well, we've got a lot of options for 120, so we have to go through a whole bunch, but it's usually a good idea. Start with the easiest thing you can think of, okay. Well, the easiest thing I can think of is it's got a 0 on the end, probably going to have a 10 involved. It could have a 10 involved. 10 times 12, oh fantastic, 12 plus 10 ends up being 22. Now, obviously I already know what this result's going to be, so I know where to start, but you literally just start somewhere and start working your way through them. When we do these, we'll run into a bit more trouble, which is fine, but it's very much you try something and then adjust as you go. Okay, so we've got these guys, okay? We need now to break those up. Okay, I need one of these numbers to be a factor of 8, one of the factors to be a factor of 15. Okay, what does 12 divide by? Divides by a whole lot of stuff. What does 12 and 8 divide by? I've only got so many options for that. Okay, well, how about they both divide by 1, obviously. They both divide by 2. This divides by 3, that doesn't. They both divide by 4. This will go by 6, that won't. They don't both go by 8. That's it. So I'm out of options. Cool. The other side, well, I can't go by, and then I need these two times together, so that would be 12, this would be 6, this would be 3. Alright, well, this doesn't divide by 12, this doesn't divide by 6, it does divide by 3, so that gives me my set there, 4 and 3. Cool, over on this side. Alright, we'll change colour. Yeah, let's change colour, why not? Cool, so over on this side, alright, I need factors of 10, alright, that go into 8. Okay, well that's 1, 2, that's it. Don't have any others, okay, so this would have to be 10 and 5. Cool, factors of 10 that also go into 15. Well, that doesn't go, so I'm down to 2 and 5. Brilliant. So our numbers are going to be 4, 3, 2 and 5. Now we just have to figure out how they go together. Okay? We know that we're going to have x here, x there. Okay? Everything's positive, so I can put that in now. Alright. Two numbers that multiply to 8. And I always have the front number, so it's 2 and 4. I'll put the 4 on the left, since it's already there. And I'll put the 2 on the right. So if I was to expand this, I'd get 4x times 2x, which would give me 8x squared. Great. Now, this is in the same box. If it's in the same box, they have to be in different brackets, because I need the 4 to multiply by the 3 to get the 12. So they have to be multiplying, so the only way they can do that is if they're in different brackets. Go. Similar story, the 2 and the 5 have to be in different brackets. There's only one spot the 5 can go now. Done. Go. Now, obviously we already know that's right, because that's just the reverse order. But you should always expand these to check them, because it is super easy to drop a negative or do something dumb. So, these two, 4x by 2x, that's 8x squared, yep. 4x by 3, that's 12x. 5 by 2x is 10x, so 12x and 10x, that gives me 22x, brilliant. 5 by 3, 15, great. So that's how we do that. It is reasonably short compared to this, but it is a little bit fiddly. So let's go another one so that we've got our wits about us. Cool, first thing, assuming we've ruled out everything else, so we can't factor anything out, no, we can't do recognition, we can't do difference of two squares, we can't do grouping. Trying to do completing the square would have to divide everything by 12, and that's not going to look particularly nice, so we'll try Berry first. Okay, first and last, multiply together, so I get 24. Break that up into two numbers. These two numbers have to multiply to 24 and add to 11. Okay, what does 24 break into? Well, I can have 1 and 24, obviously that's too big. 2 and 12, well that's no good. 3 and 8, is that what I did? Yep, 3 and 8, yep, that goes to 11. Beautiful. And we could keep working down the list until we find it. Cool, so we've got 3 and 8. Cool, you could have 8 and 3 as well, it doesn't matter which way around these go. Cool, we now need to break that up. Okie dokie. I need numbers that are factors of 3, well that's only 1 and 3, no matter what I do. And both of these are also factors of 12, so we're okay. Cool. So that's that, that's good. Yes. Cool. So it could be 1 and 3, or it could be 3 and 1, which is kind of unsurprising because it depends which way around you go. Okay, fine. Blue was the other colour? Yes, blue was the other colour. Okay. Now, this is going to be going, so if 1 goes to 3, then 3 has to go to 2. Well, that's no good, that's not a factor. So I can't have that one, so I must have 3 and 1. Cool. Factors of 8 that are also factors of 12. Okay, well 1, 2, not 3, 4, and 8 isn't, so I'm done. Great, so this would have to be 1 with 8, 2 with 4, 4 with 2. Cool, these are factors of this. I need ones of this that are factors of that. 8, no, 4, no, bang, 4 and 2. So I've got my numbers, 3, 1, 4 and 2. Now it's just a matter of which order they go in. We know that we're going to have two brackets here, we're going to have x, all of these are positive, so we'll put in the plus now. Great. Okay, this 3 up with this, so 3. Okay, the 1's in the box, so it has to be in the other bracket. Cool. 3 times 4 gives me my 12. They're in a box, so they have to be in different brackets. There's only one spot to go anyway. Cool, okay. Now we don't know if this is right, so we better check it. 3x by 4x gives me 12x squared. Yep. 3x by 1 gives me 3x. 2 by 4x gives me 8x. 3x and 8x gives me 11x. Yep. 2 by 1 gives me 2. Yep, that all works out just fine. Again, if you ended up with these the other way around, that's fine. A times B is the same as B times A for this, so it doesn't matter. Cool. Next one. First thing times last thing. After you go through your whole list, it won't work. So this thing times this thing. Now, this is getting a little bit chunky, boy. 630. Geez, that sounds like it's got a lot of options. That's not good. Also, it's negative. Oh, bother. Well, I guess we're going to be here for a little bit of time. Well, maybe not. Let's start working through some of these things. What are some obvious things? Well, it ends in a 0. So, rather than starting at 1, because I'm going to end up with 1 and 630, which is a little way off 17, so we can jump a few in this. Okay, what happens if we pick 10 and 63? Okay, one of these has to be negative. I'm going to make, doesn't matter, I'll make this one negative. Okay, 63 minus 10 is 53. I'm still a long way off. All right, what else does this divide by? Well, it looks like it divides by 30, because divide by 3, divide by 3. Okay, so let's try 30. This gives me 21, I think. Double check. Yes, cool. And for argument's sake, I'll make this minus. Okay, negative 30 plus 21, well, that gives me negative 9. Oh, well, that dropped off really quickly, and we went past. So originally, this gave us whatever it was, 53. This gave us negative 9. We've gone too far, so it must be somewhere in between these. Okay, what else can we divide by? Well, if I can divide by 10, if I can divide by 30 and 21, there must be some extra, excuse me, there must be some extra space in here for factors of what? So we've got factors of 7, 3, 2, 5, and 3. Or 2, 3, and 5, I should say. Okay, what else can this thing divide by? Well, let's think them through. Let's go, can we divide by 20? No. Can we divide it by 15? No, because that would be halved. Ooh, what else can we divide by? 12s and such, I suspect. Alright, cool. So we're going to have to do a little bit of a trick here. Okay, so I've got 10 and 63. What can these divide by? That divides by 2 and 5. What does this divide by? 3 and... 9 and... Well, we'll go 7 and 9, right? But I can break that into 3 and 3. So what we want are combinations of these numbers. So if I have 2, 5, and 7, I need to multiply that by 3 and 3. So another combination I could have been, say, negative 9 and whatever this is, 70. Cool. Now, if I do that, what have I got? I've got 61. Well, I'm moving further away. That's no good to me. So there must be a gap in here somewhere. Minus 30, and whatever we had, 21. Okay, well, what if we do another mixture of these? Well, okay, I've got a 5 and a 3, so I could do 15. And then we'll keep that as negative. Cool, well, I don't know what this is divided by 15. Wait, no, I could have done 15. Is this wrong? This is 21, yeah, that's right, okay. Oh, shift the 3 across, that's why, oops. Okay, so I've got 15, gives me the 5 and the 3. Okay, I've got 21, gives me 42. Okay, 15 minus 42 gives me what? Oh, the other way around, sorry. 42 minus 15, I should say. So we got 32 is 20. It's still going to be wrong anyway because we need a negative. We'll make... No, actually we'll leave that there, sorry. Never mind. So what do we got? 27. This 27 is 30 is 42. Yep, cool. Alright, well, 27 is closer to 17, so we're making progress. Cool. What about 3 times 3 times 2? Okay, well, that'd be 18. So 3, 3, 2, and 35. Okay. Negative 18 and 35 gives me positive 17. Well, now we're right on close. We just need to flip the negatives of that. So we've got positive 18, negative 35. And you could write them the other way around, that's totally fine. That's about as hard as these will get. So whenever you get stuck on them, you just pick something that's obvious that it divides by, try to find two that are obvious, as in two pairs. Then see, do you want to go higher than that, lower than that, or in between somewhere? And then if you can't think of those factors, just write out all the factors, everything, multiply them together, and start mixing and mashing your factors. Cool. Break, 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 break. Cool. All right, I need something that goes into 18 and 30. All right, well, it could have 1, could have 2, could have 3, can't have 4, can't have 5, can have 6. What else do we get? So this will divide by 6, by 9, that doesn't divide by 9, and we're out of options. Brilliant. Okay, so this goes with this, goes with this, goes with this, and we're out of options. Okay. Alright, well, what does this divide by? Negative 21. Well, no, that's no good to me. No, that's no good to me. No, that's no good to me. It must be this. Okay, over to the other side, negative 35, and also divides by 30. Okay, well, 1, not 2, 3, no, 4, 5, yes. And that's the last thing these two are going to have in common. We could go through the list, but that's the last set. Cool, so that must be negative 35 and negative 7. Okay, this doesn't divide by negative 35, so he's out, so it must be these two. Cool, so we've got 6, 3, 5, and negative 7. Open up our brackets. They're not all positive, so I won't write in the plus this time. Okay, first one is 6. 3 must go in the other one, it's a positive 3. First one is 5. Negative 7 must go in the other one. Cool. Now it is not at all obvious that this is right, because we were struggling with these a bit. So 6 by 5 gives me 30, x squared. Yep. 6 by 3 gives me 18. Negative 35, so 18 and negative 35, that gives me negative 17. Yep. Negative 7 and 3 gives me negative 21. Beautiful, we're happy. That's about as hard as they can get. Cool. Next example. Okay. 10 and 18. Okay, 180. It's all positive, so that's fine. Two things that times to that. Okay. Run down the options. Well, the obvious thing to do would be 10 and 18. But that adds up to 28. We wanted negative 27. Ooh, well, if I make these negative and negative, then I'd get negative 28, and I'm already really close. So this is where just picking obvious things can sometimes help you out really quickly. Okay, what else can this divide by? Well, it divides by 9, so we'll try negative 9, excuse me, and negative 20. Well, that gives me negative 29. Ah, we went the wrong way. Okay, so can we go up to 11? Does this thing divide by 11? No, it doesn't look like it. Does it divide by 12? Well, let's find out. So, negative 12, okay, and what's this going to go to? This is going, 12 plus 6 is 3 is 15. So it'll take a little bit of fiddling around, but eventually you get there, and sure enough that gives me negative 27. Yeah, you're quite welcome to use another scrap of paper to figure out exactly what goes to what. These will take a little bit of time until you can get all your factors in your head nicely, which is why we're doing all that times table speed. Okay, so I've got negative 12 on one side, negative 15 on the other. Okay, split that. Cool, negative 12 and 10, both divide by 1, both divide by 2, not 3, not 4, not 5, not 6, nothing. I'm done. So that's negative 12 and negative 6. Okay, 18 does not divide by negative 12, does divide by negative 6. Even though it's negative, it's fine, because we can do negative 3 times negative 6. So that's okay. Cool, other side. Both divide by 1, always. Both divide not by 2, not by 3, not by 4, yes by 5. And that's as far as it goes. Everything else you can check, but that's it. Okay, on the other side, this must be negative 15 and negative 3. Cool, the negative 15 doesn't go with that. Negative 3 does, okay. Cool, put them into brackets. They're not all positive, so I won't put those in. Okay, first one into the 2. Oh, I did that in the wrong colour, sorry. Let's fix all that up in colours, because it's always nice if it looks right. Cool, so what do we have? 1, 2, that's it, alright. Negative 12, negative 6. That can't go into that, so we've got 2 and 6. Blue boy. 1, what are we going with? This and this. 1, no 3, just 5, yep. Negative, sorry, positive 18. Sorry, these should have been, yeah, sorry. Oh, jeez. Negative 15, that's better. These two times this times this. Go. That's a 3. There we go. This doesn't go with this does go with this, so we've got our numbers, great, that's 5. Cool, 2, yes, so the 6 must go over here. 5, so the 3 must go over there. Beautiful, as always, check to see if we're good. 2 by 5, 10, yep. 2 by negative 6, negative 12. Negative 3 by 5, negative 15. 12 and 15, 27. They were both negative, so negative 27. Negative 3 by negative 6 gives me positive 18. Beautiful, we're all set. Okay, last one. Still look at this. Great. Well, let's try and see what happens. Cool. 3 and 5 gives me 15. Well, that seems like it should be reasonable. Okay, well, what are my factors of 15? I could go 1, 3, 5, and 15. So 15, 5, 3, and 1. Okay, I could have these, or they might be negative versions. Okay, well, that gives me 16, that gives me 8, that gives me negative 8, that gives me negative 16. Oh dear, none of those work. We're out of options. So in this case, we get stuck. So this won't work for absolutely everything, which is a little bit irritating, but que sera. One way that you could do this is take out a factor of 3, so this becomes 4/3 and 5/3, and then run completing the square on it. Unfortunately, sometimes the numbers just aren't nice. For the most part, that you won't be given those without one other technique that we're going to learn. So this one, not the easiest thing in the world, takes a little bit of effort, but can be done with a bit of perseverance. It's usually a good idea if you systematically list off your factors if you get stuck. If you can, just pick one at random that's nice and easy, ideally pick 2, and then see which way you need to go. And then if you're not making much progress, start doing it systematically. Just start with the smallest factor and work your way up. Cool. Email me if you get stuck. Best of luck. Cheerio.